Hello friends, welcome to my channel. We have given a problem of definite integration. We are going to use the substitution method to solve this problem. So first of all, substitute cos x upon 2. So let cos x upon 2 equals to u. So cos x equals to this, cos x equals to 2u. Differentiating with respect to x, both sides, this becomes minus sin x dx equals to 2 du, and sin x dx can be written as minus 2 du. Again, so we are going to find out the limits of integration at x equals to 0. U equals to cos 0 upon 2, and cos 0 is 1, so this is 1 upon 2, and at x equals to pi, u equals to cos pi upon 2, and this leads to minus 1 upon 2. Again, we can write this integral as minus 1 upon 2 to minus 1 upon 2. This is e raised to power mod 2u, and this can be written as 2 sin u, and this is plus 3 cos u, and this is minus 2 du. So this integral can be written as, again we can write this integral as the sum of two integrals. As the sum of two integrals, this can be written as 1 upon 2 to minus 1 upon 2 e raised to power mod 2u minus 4 sin u du, plus, and this is plus 1 upon 2 to minus 1 upon 2, and this is minus 6 e raised to power mod 2u cos u du. Again, we can change the sign of integral by changing the limit of the integral. So we can make it positive by changing the limit of integration. We can write this as sin u du, and this can be written as 6 1 minus 1 upon 2 to 1 upon 2 e raised to power mod 2u cos u du. So we know that this function is odd function, so this is odd function, why? Since sin minus u equals to minus sin u, and modulus function is even function, so product of even and odd function is odd function, and this is even function. This is even function, since cos of minus u equals to cos u, and e raised to power minus 2u is equals to e raised to power mod of 2u, and this is equals to, these quantities are equal. So the product of even function is even function, then product of even and odd function is odd function. So by using the property of definite integration, we know that minus a to a fx dx is 0 if fx is odd, and this is 2 times 0 to a fx dx if fx is even. Therefore this integral becomes 0, and this integral can be written as 6 times minus 6 into 2 times 0 to 1 upon 2 e raised to power mod 2u cos u du. So we have to find out this integral. The above integral is equivalent to this integral, so we can, again, this can be written as 12 e raised to power 0 to 1 upon 2, and again we are knowing that modulus function is positive in the greater than this mod x is greater than 0, so this can be written as 2u cos u du. Again, we have to find out the value of this integral. So first of all, we are going to find out the value of the integral. So let I equals to e raised to power 2u cos u du. So take it as, so this as second function and this is as first function. Where we are going to use integration by part. So we can integrate this as integration of integration of e tu du, and we keep a cos u outside the integral, and again we differentiate cos u and integrate e to u du, and again du. So this is the method of integration by part. So we can use this method to integrate this function. Again we can write this as cos u e raised to power 2u upon 2, and this can be written as, this is minus sin u, so this is minus sin u, and this is e raised to power 2u upon 2 du. Again we can write this as, we can write this integral as e raised to power 2u cos u upon 2, and this can be written as minus plus 1 upon 2 e raised to power 2u sin u du. Again we can write this integral as, this is, we again use here integration by part. So this is the, this is first function, we can take this as first function and this as second function. So we can e raised to power 2u cos u upon 2 plus 1 upon 2, and again this is sin u e raised to power 2u du minus d upon du sin u, and this is e raised to power 2u du. Again this can be written as, again this can be written as du. So this integral becomes e raised to power 2u cos u upon 2, this is I, and we know that this is I, and this is 1 plus 2 sin u, this is sin u e raised to power 2u upon 2, since integration of e raised to power 2u equals to e raised to power 2u minus upon 2, and this is minus cos u, and this is e raised to power 2u upon 2 du. So using these relations we can write that I e raised to power 2u cos u upon 2, and this is plus, sorry, this is, we have integrate this function, so this is not an integration sign, so this becomes e raised to power 2u sin u upon 4, and this is minus 1 upon 4 e raised to power 2u cos u du. So what, this is what we have taken this as I, so our integration problem becomes, this is I, so I equals to e raised to power 2u upon 2, and this is 1 upon 2 sin u plus cos u, and this becomes minus 1 upon 4 I. So we have known that this, the integral of this value we have taken as I, so this becomes 5 upon 4 I, adding, we can add, this becomes I plus 1 upon 4 I, and this becomes e raised to power 2u upon 2, and this is 1 upon 2 sin u plus cos u, and this becomes 5 upon 4 I equals to e raised to power 2u upon 2, and this is 1 upon 2 sin u plus cos u. Again we can, so value of I is equals to 5 upon 8, this is, sorry, this becomes, this is 2 upon 5 e raised to power 2u, and this is 1 upon 2 sin u, and this is plus cos u. Again we are going to, we have to find out the value of this integral, so we have find the value of this indefinite integration, or we have to put the only limit of the function. So what we do, again we have to find out, so we have to find out 12 times 0 to 1 upon 2 e raised to power 2u sin u, sorry, this is cos u du. So value of this integral is, we have value of this integral is 12 times, and this is 2 upon 5 e raised to power 2u, and this is 1 upon 2 sin u, and this is plus cos u 0 to 1 upon 2. So we can put the value of integration as 12, this is 2 upon 5 e raised to power 2 into 1 upon 2, and this is 1 upon 2 sin 1 upon 2 plus cos 1 upon 2, and again minus this 2 upon 5 e raised to power 2 into 0, and we can write it as 1 upon 2 sine 0 plus cos 0, and this is the value of integration. So we are looking here that by solving this we can take 2 upon 5 as a common, so this becomes 24 upon 5, and this is e raised to power 1, and this is 1 upon 2 sine 1 upon 2 plus cos 1 upon 2, and this is minus this is 1 and this is 1. So this is the value of integration. So we have found that the answer of the above problem is, so we have found that the answer of the problem was 0 to pi e raised to power mod cos x, and this is 2 sine of cos x upon 2, and this is plus 3 cos of cos x upon 2, and this is sin x dx equals to 24 upon 5, and this is e raised to power e into 1 upon 2 sine 1 upon 2 plus cos 1 upon 2 minus 1. This is the answer of the given problem. Thank you.